This video is a tutorial on how to run the DART mass spectrometer instrument, and this is assuming that everything is closed and you just walk up to the instrument. The first thing that you do is you open the helium valves. So the first is the metal one on the top, and then the two stoppers before the filter and after the filter. So the next thing that you do is you open up this window right here. It's called Mass Center Main, and this is the main controller for the AccuTOF instrument. So right now, this is the project view where it's spring 2016. You can ignore this single acquisition thing. To start running an analysis, you can click on this MS status panel right here where it says warm up, and then open this window and click on this button called MS Tune Manager. So open that. What will open up is the tuning program to control all the voltages for the AccuTOF. So here we have the EI source information, which will not be used. However, we will use this tab right here, which is the temperature and gas controls for the AccuTOF front end. And this window over here are the analyzer voltages that control this region over here. So this we won't use either. Do not touch these voltages unless you know exactly what you're doing. And these voltages are related to the tune file that is loaded. So up top over here, it's going to say untitled. If you're ever unsure, you can go to File, Open MS Tune Method, or you can click on one of these tune methods over here. The safest one to open is DART plus tuned 010516 at 25 volts. Actually, open this and just click modified and look for the most latest modified method, which is this 15 volt one over here. So open that, and what that will do is that this will change all these voltages to the parameters that were saved in this file. So this will change right here, and this indicates that this tune file was opened to where these voltages were applied. So the first thing that you're going to do is turn on the detector. So you set that to 2200 volts, 2200, and press enter. So make sure to press enter to change the voltage of this detector over here in this region. The next thing that you're going to do is go from warm up to operate. And you'll hear the instrument click, and that means a connection was made to turn the voltage of the fast flight and the orifices on to start the heating process. So what this will do is that this turns orifice 1 on, and this will heat up to this 80-degree set point set here. What's going to happen is that orifice 1 will go up to 120 degrees about, and then slowly come down. So what you're waiting for is to be 80 plus or minus 15, but if you just turn this on to operate, don't start your analysis right away. At least give it a couple minutes to let it equilibrate. You won't need the nebulizing or desolvation gas because that's for electrospray, so you can ignore these. Just make sure that orifice 1 has been clicked. The voltages for this tab you won't need to change, but in the case that you do, for ring lens voltage, 10 is the default, 20 is the default for orifice 1, 5 is the orifice for orifice 2. And what you can do if you want to do in-source fragmentation, so produce fragmentation products, all you have to do is increase this voltage up to 100, and what you do is take the difference from this point right here to this point right here. So right now, this is set to 20, this is set to 5, so the voltage difference, or the potential, is 15 volts. So from here to here. That means a 15 volt potential will be applied to transmit ions from this point to this point. And that's what's set within this tune method right here. As you're waiting for this to warm up and then cool down, open the browser. And this is a Chameleon browser. The reason why we use Chameleon is because Firefox or Google Chrome is too resource intensive that it will lag the computer. This will typically be set to off. So what you can do is set it to standby. And what standby does is that it will blow nitrogen gas as the gas heats. So what you want to do is turn the heating block in the ion source on to 350 by default and let it ramp up. As you're waiting for these temperatures to go up, so this temperature right here to come down to 80 degrees or close to 80 degrees, and this to come up to 350, you can also view the mass spectrum right now by turning on the voltage to the ion source and flowing helium. So this will turn on the ion source. So once these temperatures are to set point, you can start your analysis. Alright, so I just unpaused the recording to allow everything to hit temperature. So right now the heater temperature on the DART ion source is about 350, if not 350, and it's already set to run. You don't have to set it to run before it hits temperature. It could have also been on standby, and you can see that there are no ions being transmitted. Either way, it doesn't matter. Setting it on standby and allowing it to heat will save helium. So what I'm going to do is set the voltage on the ion source to have it be ready for running. Minimize this. And what you see here is the background mass spectrum of the open air region of the ion source. Also, you can see that the orifice 1 temperature is about 89, and this is okay as long as the value is plus or minus 15 degrees. All that matters is that you left adequate enough time for this to equilibrate and stabilize. So to start an acquisition, make sure that all the voltages are correct. So the detector voltage is on. Make sure of that. The orifice 1 and orifice 2 voltages are set. So in this case, I'm doing an acquisition of 15 volts, stated here, and as stated in the tune file. And if you wanted to change that, go ahead and do that now. Keep in mind that a higher potential will increase the fragmentation. So to make an acquisition, go to this top menu, click Acquire, Start Acquisition, and this wizard will pop up right here. You don't have to set anything in this page. However, click Next and fill this information out right here. So the acquisition data is in the format of name _ date. In this case, my name will be Patrick _ the date, which is 040516. The external and internal ID, you don't need to fill these out. You can fill the comment box if necessary, but the most important place is the acquisition data folder for which this file will be saved. Make sure that this is in the correct month. Right now it's April 2016. However, if it's a different month of you viewing this, go ahead and change that and make a new folder. If not, if it is the correct month, then you can just click Finish. It says that this file exists because I've already ran an analysis, so I can just overwrite this and click Yes. In many cases, this won't pop up. Alright, so the acquisition will start to initialize and windows will pop up. The first window is Spectrum Viewer. where the mass spectrum will be. And then the next window will be the chromatogram viewer. And then the start run window right here. So I first like to maximize these two boxes within these windows. So just double click on the bar. And then I like to put these two windows into the next monitor that will not be shown, but it's to the top right. Just to position everything out of the way. So now, when I'm ready to acquire data, I just click Start Run and do my acquisition. The first thing that I like to do is acquire the mass spectrum of polyethylene glycol PEG 1000, and then just start doing the regular samples. So when I'm done with my acquisition, what I'm going to do is go back to this Mass Center main window and click Stop right here. So Stop Acquisition / Continue to the next acquisition. Assuming that I'm no longer acquiring any mass spectra, go back to Tune Manager, turn off all the voltages, so the detector 0, and you can see that the mass spectrum will have 0 signal. Set this back to warm up, and you'll hear the instrument click. What happens at this point is that this temperature will drop down as the heater will no longer be operational. Also, set this to stop, the spectrum monitor to stop. And this will stop moving right here. After that, you want to cool down the ion source, so open up this browser again, set this to standby, and then heater off. What you're waiting for before you turn it off completely is for this temperature to go down to 200 degrees or below. I've unpaused the video for a while to allow the DART ion source to cool, and you can see that the temperature is almost 200 degrees. So I will set this to off as soon as it gets lower than 200 degrees. And the reason why we do that is because you can burn out the filament if you stop gas flow from protecting that filament prior to it cooling down adequately. So now that it's less than 200, I can go ahead and click off. And then close this browser. The next thing that I do is that once I'm absolutely sure that I'm done doing my analysis, I'll check that the voltages are off, so that the detector is off. Hit enter, just make sure. This is set to warm up, and this is set to stop. Everything else you can ignore, and now you can proceed to your data analysis, which will be in another video.